You know what noise is, right? It's that static, that annoying hum. It's the stuff we're always trying to get rid of so we can hear what we actually want to hear. But what if that noise? What if it was the most important signal in the universe? So let's really dig into this idea. Because that one question, that shift in thinking, completely flipped our view of the cosmos. It's an incredible story about how, for astronomers, the very definition of noise versus signal has done a complete 180 over the last 100 years or so.
Our story kicks off in a pretty unexpected place, not in some grand observatory, but at a telephone company back in the 1930s. And it all starts with an engineer just trying to solve a really practical, kind of boring problem.
Bell Labs was rolling out this amazing new service, radio telephone calls across the Atlantic. Total high-tech stuff for the time. But there was a snag. This persistent, irritating hiss was messing up the calls. So they gave a young physicist named Carl Jansky a simple job. Find out where that noise is coming from and make it go away. He wasn't on some grand quest. He was just doing tech support.
Well, Jansky turned out to be a fantastic detective. He built this huge rotating antenna and started tracking down the sources of static. Sure enough, he found some of it was coming from distant thunderstorms. Makes sense. But there was this one faint hiss that just wouldn't quit. And here's the kicker, the clue that changed everything. It didn't peak every 24 hours like you'd expect from something related to the sun. It peaked 4 minutes earlier each day. That's sidereal time, star time. This hiss, it wasn't coming from Earth at all. It was coming from the stars.
And right there, in that moment, the entire mission flipped. The annoying static he was supposed to eliminate was the discovery. That cosmic noise was the birth of a whole new science. It's wild when you look at the timeline. I mean, we'd known about radio waves for almost 50 years, but it never occurred to anyone to seriously point a receiver at the sky. After Jansky's discovery, this amateur radio engineer, Grote Reber, got so inspired he literally built a 31-foot radio dish in his own backyard to start mapping this star static. These guys were inventing a field from scratch. And you know, this whole incredible story, a phone company accidentally kicking off a scientific revolution, it's all chronicled in the history books of the field. It really documents how investigating something dismissed as cosmic noise created an entire new discipline, radio astronomy. And this quote just perfectly captures the absolute magic of that time. Just stop and think about that for a second. For the very first time in human history, someone could watch a constellation rise during the day on the needle of a voltmeter. They were seeing a totally invisible universe. The noise had become the entire show. So this really gets us to the heart of the matter. The role of noise has completely flipped on its head. For Jansky, the whole goal was to hunt down and listen to that mysterious hiss. Today, astronomers are trying to hear an even fainter, more ancient signal, and noise is the enemy all over again. Only this time, the noise is coming from inside the house. It's their own instruments. All right, let's jump forward to today. Because this modern struggle with noise isn't about getting a clear phone signal. It's about trying to see the very beginning of time itself. What modern astronomers are hunting for is the ultimate prize, the cosmic microwave background, or CMB. This is literally the leftover heat from the Big Bang. It's this incredibly faint glow that fills the entire universe. You can think of it as the universe's baby picture, the oldest light we could ever hope to see. It's got all the secrets of how everything got started. But here's the great irony. Our telescopes have become so ridiculously sensitive that they can hear their own electronics humming. This instrument noise is the new static, and it's often way, way louder than the ancient signal they're trying to catch. So just like Jansky, they're staring at a wall of static. The big difference is, this time, they know there's a Nobel Prize-winning message buried underneath it. So, how in the world do you solve this new noise problem? It's not about building a better antenna anymore. The solution today isn't in the hardware, it's in the software. It's about fighting static with pure, beautiful math. This graph shows you the problem perfectly. You see all those scattered X's? That's the raw data. It's a total mess, completely overwhelmed by the telescope's internal noise. But hiding under all that chaos is the real prize. That clean, dashed line. That's the actual signal from the dawn of time. The entire job is to figure out how to pull that perfect line out of that noisy cloud. And the way they do it is just so clever. It's a loop. First, they make a rough guess of what the sky map looks like. Based on that guess, they can calculate the exact noise fingerprint their instrument would create. Then, they just digitally subtract that fingerprint from their messy data. That leaves them with a slightly cleaner signal. So what do? They use that cleaner signal to make a better guess of the sky map, and they just repeat the process, again and again, hundreds of times, each loop cleaning up the picture just a little bit more, until the true signal finally emerges.
So when you take a step back and look at this whole journey, from signal to noise and right back again, what does it all tell us? It shows us that this constant battle with noise has been one of the most powerful engines of discovery in science. First, by realizing some noise was actually a signal from space, which was a revolution. And now, by inventing these incredible ways to remove our own noise to find an even deeper signal, another revolution. So imagine the raw data streaming from one of these new telescopes. It's a sea of information, yeah, but almost all of it is just the telescope talking to itself. The universe's oldest secret is whispering in there, but it's completely drowned out. But then you run it through that mathematical filter. The static gets peeled away, layer by layer. And what's left behind is this, a crystal clear map of the infant universe, a picture from 13.8 billion years ago. The signal, finally free. It really makes you wonder, doesn't it? We've gone from a telephone company's static problem to seeing the echo of creation itself. It proves that one person's noise can be another person's life's work, which leaves us with this incredible, lingering question. What are we all dismissing as just noise today that might turn out to be the most important signal we've ever found?